Section 1-3 is called Measuring and Constructing Angles. So we're still chapter 1, the third section. Most of you have seen an angle before, but basically an angle is going to be formed by two rays. They have what's called a vertex. That's the common endpoint that they both share. So if you draw an angle on your paper, make sure you put little arrows on each end. We're going to talk about special ways that you need to name this angle. Okay, so we're going to put some points on it. We'll call this point right here S, this one R, and this angle T. And so this is going to be angle SRT. Bless you. You can also name it the other direction, angle TRS. What letter is in the middle on both of those? R. Why? Because it's the vertex, okay? The vertex has to be the middle letter, okay? Sometimes you have a number inside of the angle, like there might be a 6 right there, and you might call this angle 6. That's usually when you have multiple lines intersecting, creating multiple angles, and they would all be numbered differently, like 1, 2, 3, 4, 5, 6, 7, 8, okay? And so you might be able to refer to an angle by a number, but usually it's the letters, okay? And once in a while, you can just call it angle R, but that's only if there is one angle. If there's more than one angle, you can't just use the vertex letter. You have to use all three. So this one and this one, most of the time, like 95% of the time, you're going to have to use all three letters with the vertex in the middle. All right? So angles also have an interior and an exterior. There is a measure of an angle. 360 degrees is the total. This little symbol right here is called degrees. And then last week we had the ruler postulate. So today we're going to have what's called the protractor postulate. And just like the ruler postulate, the protractor postulate is going to have what we call a one-to-one correspondence. So basically, every number that you see on your protractor is going to match up to an angle. Bless you. Okay. And then let's talk about types of angles based on measurement. First one we're going to look at is called acute. So anybody know how many degrees an acute angle has? Well, 45 would be an acute angle, but there are others. 45 and lower, but it goes a little higher than that. Below 9, we'll say less than 90 degrees, okay? So you might have something in this range. 45 would be included in that, but there are a lot of other angle measures that are included in less than 90 degrees. We don't have an equal part here. Notice that I'm saying less than 90, but I don't have the equal. That's because the next one is equal to 90. Who knows the name of that one? Right. Oh, you all know it. Good. So a right angle is exactly 90 degrees. And it's kind of like the corner of your paper or the corner of a book, right? Exactly the corner. And we're going to put this little box there. That's the symbol for a right angle and always represents 90 degrees. Okay, so we have less than 90, equal to 90. What's the next one? Obtuse, right? Obtuse is going to be greater than 90, but less than 180. Okay, so something in this range. And the fourth one is one you may or may not have heard of. It's when it equals exactly 180 degrees. Anybody know this one? Straight. So a straight angle is exactly 180 degrees. It basically just looks like a line. Or opposite rays. Okay. The next topic is the angle addition postulate. Bless you. So the angle addition postulate is kind of like the segment addition postulate, right? Remember when you take one part of a segment plus the other part of the segment, you add them together, it equals the whole thing. So the angle addition postulate is going to be the same way. You're going to take one angle, add another angle, and it's going to equal the whole thing. Okay? So we're going to draw angle RQS right here. There's RQS. And it's going to be adjacent to angle SQP. So I'm using this word adjacent. Adjacent just means next to. This postulate says that if we take this first angle that we drew, so the measure of angle RQS plus the measure of angle SQP is going to be equal to the whole thing. So this little angle plus this little angle equals the whole angle, RQP. All right. I'm going to move this up. You'll see it in just a second. There it is. All right, so that leads us to example number 1, where we're going to add some angles together. We're going to use that angle addition postulate. And here is the first piece of information. The measure of angle DEG is 115. The measure of angle DEF is 48 degrees. We are going to find the measure of angle FEG. All right, so the first thing we should do is what? Draw it, right? Because we've got some information there. We don't know which angle is which. All right. We know that the vertex should be what? E. We know that because it's in the middle of both of those, right? You see the E in the middle and the E in the middle? That means we're going to make a vertex of E. Both of these angles, that's a horrible G. Okay. Both of these angles also share what? D. So from E, I'm going to come out here and I'm going to put D. Now, I know that DEF is 48, so here's D, E. I'll put F here, and we'll label it, we'll put a little 48 degrees in there. Now I've also got DEG, so here's DE. I'm going to put G over here. so that it's about 115 degrees. Now, I'm not going to put 115 here because that would only be angle FEG, which is what I want to find. So I'm going to put an X there, or you could put a question mark, or whatever variable you like. Maybe you like L, because that's what your name starts with. Just pick any variable. Okay, I'm going to put an X. And for the 115 degrees, I'm going to go like this. I'm going to say, I'm going to try and connect it like a little rainbow on the outside to show the whole thing is 115 degrees. Okay, now we just learned about the segment addition postulate. And the main word is addition. But am I going to use addition? No. I actually need to use the opposite of addition, which is subtraction, because this angle plus this angle equals the whole thing. So I'm actually going to end up subtracting. If I say X plus 48 equals the 115, I'm going to subtract the 48. And I should get X equals 67 degrees. And that's the measure of angle FEG? FEG. And they put that little M out front. That little M just means measure of FEG. Sometimes you'll see it with the little M, sometimes you won't see it with the little m. All right. Now let's talk about if they give you this word angle bisector. Okay. Sometimes the ray in the middle is just kind of at a random spot, but then sometimes they'll say it's specifically the bisector. So this is two words put together, right? This BI we saw, we saw midpoint, right? But bi just means two. We're going to cut it exactly into two pieces. So if I draw angle, what are we going to call this one? LJM. Here's angle LJM. An angle bisector is going to go exactly in the middle, cuts it exactly in half. Exact. Oh, I'm switching my, okay, let's try that again. Exactly in half. Let's spell exactly correct. Okay, so let's see what you're going to get for a problem that uses bisector. So example number 2, we're going to say that ray KM, bless you, is the bisector of angle JKL. So the measure of angle JKM is 4x plus 6, and the measure of angle MKL is 7x minus 12. So we are asked to find the measure of angle JKM. Woo, that looks complicated, right? Looks super complicated. So what's the first thing we should do? Draw it, okay? We know that KM is the bisector of that angle, so draw this angle, JKL first. Make sure you add your little arrows, right? We'll call this one J. We'll call the vertex K. We'll make a point over here, L. There's our angle. We know that it has an angle bisector of KM. So from K, I'm going to go straight out, down the middle, and add ray KM. Bisects it. That means this part of the angle and this part of the angle are equal, congruent, right? So I'm going to put what's called a tick mark on the arc mark, which will represent that they should be equal, okay? So if JKM is 4x plus 6, I'm going to label it. Here's JKM. I'm going to write 4x plus 6 right here. And MKL, here's M, here's K, here's L. I'm going to write 7x minus 12.